So the median, again, is just a fancy word for the middle number. So if I wanted to find the median of the numbers above, I can't just start crossing off numbers like this because I'm not going in a specific order. Okay. If I wanted to find the median of those numbers, I'm going to get rid of those zeros on the end. No, I'll leave them there. I would have to start with the smallest and the largest and just cross them off one by one. And then I kind of am just working my way into the center. So that would cross into 269 and 84. And then you're just kind of working your way into the center from largest to smallest, which gives us 104 as our middle number there. So again, the goal here is that we are just trying to um, put the numbers in order and then cross them off to see which one is the actual um, number, which again, they recopy the numbers down here. I don't love that they're like in a two rows like that. I think that's a little bit confusing, but our median as we cross these out. So again, try to notice that 665 was the biggest, followed by 82, and then 269, 84, crossing my way off all the way to 104,000. So that middle number or the median was 104,000, and that average was 155,000. So when the median and the average aren't the same, something interesting is probably happening. Because if you look at our example up here, perfect example of you can't just cross off whatever you want. When you look at the weights, right, that little brief example, I would have to put them in order of size, either biggest to smallest or largest, biggest to smallest or smallest to largest. Um, and me crossing it off, 190, 215, 200 is that median. It's only 1 pound off of the mean. So again, uh, people use the word sometimes like evenly distributed, um, which is just kind of a fancy way to say that there was no outliers happening. So um, as you look at the data set down here, it kind of looks like 82, 84, 85, like those are all kind of lumped together. And then we're in like the mid 90s or high 90s, low 100s. But then there's this like gigantic, probably like Alaska or Texas, or if it's 15 biggest states, I'll say it's Alaska. You know, somebody wants to challenge me, I'm open to being challenged, but I would say it's Alaska most likely. Um, so that 665, the reason why that these are so different is that the 665 is bringing the mean, bringing that mean value so much higher. Hopefully that's making a little bit of sense. So basically, if we did that exact same thing without 665, which again is nice if you put it in Excel or Google Sheets, not to be all like dramatic and be like, oh, this is why we do this. But if you got rid of the 665 and you summed A2, which it is so smart. I don't understand how it can just know what to do, but that was great. So then you divided, if we found the average without our Alaska friend, our 662, that puts the average similar to the median, a lot closer to the median when we got rid of that huge outlier there. And notice when I messed that up, so 662 is the sum without Alaska. When I had 667, by me just adding 4 extra, it didn't really change the average a whole lot, right? So, again, when you're only adding just a little bit more, it's not gonna bring up the average. It's when you add a whole lot more that the average really like jumps up a lot higher. Hopefully, that's making some sense. Again, about the difference between a median, which is the middle, and the average, which is um, the mean.